Hi, everyone. My name is Katie Faulkner, and this is my teaching demo for CS698 Teaching Practicum. And I'm going to be teaching you how to multiply matrices. So first, let's talk about why you would want to do this. Matrix multiplication is the foundation of a lot of math, specifically neural networks and modern AI tools like ChatGPT. So this is integral to understanding how tools like ChatGPT work. First, we're going to talk about what a vector is. So vector is a one-dimensional sequence of numbers. It's usually written as a lowercase letter with an arrow over it, and an n-dimensional vector can represent coordinates in n-dimensional Cartesian space. So a two-dimensional vector would represent coordinates on a 2D XY axis, whereas a 3D vector could represent coordinates in a three-dimensional space. Individual numbers in a vector are called components and are written with subscripts. So let's look at some examples. Vector A could be 1, 2, 3. Vector B could consist of components B1, B2, B3, B4. And we could have a vector C that is a point 2, 5 on this 2D Cartesian plane. And it's important to know we'll be working with simple integers for this tutorial, but the elements of your vector can be any kind of number. They can be huge numbers, they can be decimals, they can be fractions, anything like that. So first, we're going to talk about how to multiply vectors. And this is the dot product or the scalar product. There's another vector product called a cross product that we're not going to be talking about today. So a scalar is a single number, like 1 or 7. It's just like a number that you're used to. And let's say we have two vectors, x and y. They have the same length or dimension. So we've got x that's x1, x2, x3, y that is y1, y2, y3. And the dot or the scalar product is the sum of the two vectors is the sum of the element-wise products. So that is, so we would say x dot y is x1 times y1 plus x2 times y2 plus x3 times y3. And it's important to know vectors must have the same length for you to take their dot product. So if x had 4 elements and y had 3, you wouldn't be able to take a dot product of those. So let's look at an example of how to calculate the dot product of vectors. Let's say we have vectors u and v. U is 3, 4, v is 1, 2. Having a look at these, they're both length 2, so we can take the dot product. So the dot product u dot v is going to be u1 v1 times u2 v2. So that's the first element of u times the first element of v, plus the second element of u times the second element of v. So that is going to be 3 times 1 plus 4 times 2. And when we do that multiplication, it comes out to 3 plus 8, or 11. So now that we know how to take the dot product, let's look at matrices. A matrix is an m by n grid of numbers. It's usually written as a capital letter, and it is m rows by n columns. So you can think of a matrix as a set of row vectors or a set of column vectors. And matrix elements are numbered with their row number, then their column number. So for example, if you had matrix A, element A21 would be the second row and the first column. So let's look at some examples. A could be a matrix that has 1, 2, 3 on the first row and 4, 5, 6 on the second row. So this is 2 rows and 3 columns. So this is a 2 by 3 matrix. Similarly, we could have B that has numbered elements, B11 through B33. This matrix has 3 rows and 3 columns. So we say this is a 3 by 3 matrix. So now we're going to get into rules for matrix multiplication. But before we can start multiplying matrices, we have to understand when we can multiply matrices. So the key thing to know is to multiply matrix A and B, A has to have the same number of columns as B has rows. And what this means is if A is an M by N matrix and B is an N by P matrix, the product C is M by P. So let's look at an example of matrix you can multiply. So here we have matrix A that's 3 rows by 2 columns, so 3 by 2. Matrix B is 2 rows by 4 columns, so 2 by 4. And we can see the middle two numbers here have to match for us to be able to multiply the matrix. And the way I think of it, the middle two numbers have to match, those disappear, and then the outer two numbers become the dimensions of the product matrix. It's also important to note that you can multiply A times B, but you can't multiply B times A. For scalars, like we're used to, A times B is the same thing as B times A, but for matrices, it's not. And a lot of times you can multiply one order, but not the other. So let's look at an example of something you cannot multiply. Here we have X and Y. They have the same dimensions, so they're both 2 rows by 3 columns. And some people get confused and think, well, if it's the same size, you should be able to multiply them. But you can't always do matrix multiplication if they're the same size. And so here we have a 2 by 3 times a 2 by 3. These middle two numbers don't match, and so we're not able to multiply them. Now let's actually look at how to multiply matrices. So when you multiply A and B, each element Cij of the product matrix is the dot product of the ith row of A and the jth column of B. So let's say we have A that is 3 by 2 and B that is 2 by 2. So our resulting matrix is going to be 2 by 2. And here we have matrix C equals A times B. So this is dot product of the first row of A with the first column of B. Here is dot product of the first row of A with the second column of B. Here is dot product of the second row of A, the first column of B. Here we've got the second row of A with the second column of B. And down here, this is the third row of A with the first column of B. And here in the bottom right is the third row of A with the second column, of B. So now let's look at an example. Let's say we have these matrices A and B. A is of size 2 by 3, so it's 2 rows by 3 columns. B is size 3 by 2, so 3 rows by 2 columns. So we have 2 by 3 times 3 by 2. The 3's in the middle disappear, and we're going to end up with a 2 by 2 matrix for the product. So here is matrix C. The C11, so the upper left element of C, is the dot product of the first row of A times the first column of B. So that comes out to 1 times 1 plus 2 times 2 plus 3 times 3. Over here in the top right, we've got the first row of A times the second column of B. So that comes out to 1 times 4 plus 2 times 5 plus 3 times 6. And over here in the bottom left, we've got the second row of A times the first column of B. So 4 times 1 plus 5 times 2 plus 6 times 3. And finally, in the bottom right, we have the second row of A times the second column of B. So this is 4 times 4 plus 5 times 5 plus 6 times 6. And when we do the multiplication, here is what we get. And then we do the addition, and we end up with a final answer of 14, 32, 32, 77. And so that is a basic example of how to multiply matrices. And I hope this was helpful. Thank you so much.